Absorbent in yellow and porous is heat. 6.4, fractional exponents. All right, now we're going to deal with exponents, but now all the exponents are going to be fractions. So let's see what that does. But before we do that, let's go ahead and review some of the properties of exponents. Like if you have x to the a times x to the b. If your bases are the same, like the x's, then what do you do with the exponents? You add them. What about x to the a divided by x to the b? What do you do to the exponents? You subtract them. And then what if you have an exponent on top of an exponent? You multiply the exponents. When you have an exponent outside of a whole bunch of things in parentheses, you basically just give everything inside that exponent. So x to the a, y to the a, and over z to the a. How about x with a negative exponent? -1 exponent. All that does is it brings that number down underneath the fraction. And then what about anything to the 0 power? X to the 0 power, 5 to the 0 power, 100 to the 0 power. It's just 1. All right, so that was a very quick review of exponents. You probably spent about a month in Algebra 1 doing and practicing all of these rules. Now it's just thrown at you in the 1 minute that I just did. But you have to remember them to do fractional exponents. All right. So here we have x to the a over b. This is an exponent, and it's a fraction. What do we do with it? We turn it into a root. We basically take the denominator and put it in the root spot. And then the numerator just stays in the exponent. So you have the root and the exponent. All right, so that's important. You need to remember how to change it from fractional exponents to a radical form. Exponential form to radical form. Simplify. So we have 81 raised to the 3/4 power. You have a fractional exponent. Let's go ahead and change it to radical form. That 4 that's in the denominator, it is now a root. And then to evaluate this, you have a choice. You can either evaluate the root first or the exponent first. It's your choice, and it doesn't matter which you do first, you will end up with the same answer. The rule of thumb is it would always be easier if you do the root first. If you do the root first, then you get smaller numbers. If you do the exponent first, you get bigger numbers. And it's always a better idea to work with smaller numbers. So let's go ahead and evaluate the root first. What is the 4th root of 81? What times what times what times what gives you 81? I think it's 3. And then you just put that 3 that's there. And then you just do 3 to the 3rd power. Answer is 27. Here's another one. Change it to root form, radical form. And then again, it's a lot easier if you do the square root first, because we all know the square root of 25 is just 5. And then to the 3rd power, 125. This one is asking you to go from radical form to exponential form. So they give you radical form, you have to change it to the other form. And there it is, 47 to the 3/5 power. Easy enough. Ooh, this one I put in here as a tricky one because there's nothing here. And there's nothing here. remember, when that's the case, we just have our regular old square root. And to write square root, that's 37 to the 1/2 power. There's an imaginary 2 here, and there's an imaginary 1 here. All right, so that's a little bit tricky, but it's like the most basic one of it all. All right, let's deal with negatives. And this one's, I don't think is in the homework, but I've seen the confusion when I've taught it in the past, so I wanted to put it in here. You have a negative in front of the problem, and then you have a negative in the exponent. They both do different things. This negative in front of the problem doesn't really do anything. You just solve it like normal. You do the 5th root of 4. The 5th root of negative 32 to the 4th power, and then you just evaluate like normal. We do the root first because it's a little bit easier. That gives us a negative 2, and then negative 2 to the 4th power gives us 16. Now this negative does something different. Remember, if it's a negative in the exponent, it brings the whole problem down in the fraction over 1. All right, so that negative brings the entire problem under 1, and then the negative is no longer there. And then you just evaluate this. There it is. I wrote it in radical form. Do the 5th root of 32, which is 2, and then to the 4th power gives you 16. So the answer is 1 over 16. So this one, know the difference between what the negatives do. This negative really doesn't do anything. It's just part of the problem. This negative, you have to take the whole problem and drop it underneath a fraction in the denominator. All right, simplifying fractional exponents. All of that led to simplifying these things. To simplify, make sure either the roots are the same or the radicands are the same. All right, so they give you a problem that looks like this. Notice the radicands, 3 and 3, they're the same. We're going to try to simplify this by changing it first to exponential form with the fractions. So this first one, the square root, remember, is 1/2. And then this one is 1/4. There's an imaginary 1 here. Okay, so from here, we just have to use our laws of exponents, properties of exponents. What you do is you add the fractions together, and you should get 3 raised to the 3/4 power. Okay, and remember, when you add fractions, you have to have a common denominator. That was the 6th grade, 7th grade standard. And so you'll have to remind yourself how to add fractions. But 1/2 plus 1/4, you have to get a common denominator, which is 2 over 4. And that's how I got 3 over 4. All right, let's do an, oh, there's the answer. Oh, so there's actually 2 ways to write the answer. I'll erase all this. You can leave it in, this is called fractional form, fractional exponents, or you can leave it in radical form, which both answers are exactly the same. Let's do another one. So here we have the exponents are the same, which means the roots are the same, but the radicands are not the same. So we have to kind of change this so that it's the same, so that there's a 5 there. All right, and so there's a nice way of changing the 125 so it's 5. It turns out that 5 times 5 times 5 is 125. So instead of writing 125, I wrote it like this. 5 to the 3rd power, it's the same thing as 125. The reason why I did that is because now we have both the bases 5. Okay? To simplify this, let's go ahead and evaluate these exponents first together. Remember, when you have an exponent on top of an exponent, you multiply them together. So that's 3 times 1/4. And then now we can just add these two exponents. Oh, it looks like they have the same denominator. Add them together, you get 4/4, which is 1. So 5 to the 1 power. It's just 5. Another example, this one. Let's go ahead and change it from root form to exponential form, fractional exponential form. There it is. Remember, there's an imaginary 2 here, so I just put it there. And then this turns into that, which is nice because now you can just subtract the exponents. This minus this. And again, you have to get a common denominator to subtract, but you should get x equals 5/6. All right, last slide for the day, but there are 3 examples on this last slide. Simplify. 16 to the negative 2.5. All right, first thing you want to look at is that negative. Remember, when it's negative in the exponent, you just drop it down in the denominator. And then the 2.5, let's change it to fraction. 2.5 is the same thing as 5/2. And then you have change it to root form. And then you got to evaluate the root. Square root of 16 is 4. And then 4 to the 5th power is 1024. So 1/1024. Here's another one. This one is really complicated. And so we're going to, there's a lot of ways to get started on this. And so that's what makes these a little bit harder than normal, is you have different ways you can get started. And depending on which way you do it, it can get complicated or it can not get complicated. This one, I think all the ways will be pretty complicated. But here's a rule of thumb. If you have a root and you have fractions in your exponents, that's the 2 forms that are together. Try to change the whole problem so they kind of have just one form. I'm going to go ahead and change it so that it's all fractional form. So the way I do that is, hopefully you guys remember how to change square root to exponents. It's 1/2. So there it is. The square root of x is x to the 1/2 power. The square root of y is y to the 1/2 power. And then everything else is the same. There's the 2/3. This x that was outside is right here. And then the -8 is there. All right, the next thing we can do, notice there's multiple x's in here. You have an x and then you have an x to the 1/2. Let's combine them by adding their exponents. And then you get x to the 3/2. Next thing you can do, let's go ahead and give the 2/3 exponents to everything inside. Give it to that, give it to that, and give it to the y. It's getting a little bit messy, but there it is. The 2/3 raised in the negative x power. The x, if you notice, you have, let me clean it up because it's a little messy. X to the 3/2, and then another 2/3. When you multiply it together, they turn out to be 1, and that's why it's just x to the 1. And then if you distribute this in, the 1/2 with the 2/3, you get 1/3. All right, we're almost done with this problem. Remember, the negative in the front doesn't really do anything to the problem, you just evaluate. So I'm going to rewrite this so I can evaluate it in root form. I also did the 1/3 in the root form. We do know what the third root of -8 is. That's just -2, and then -2 squared is 4. And so that's our final answer. Again, that was a very complicated problem. It looks not too bad, but there's lots of steps to it. There's lots of different ways you could have done that problem. But It's a tough one, so if you're struggling with that one, it's okay. We are going to practice more of those on the homework. Last one for the day. Here we have negative exponent with a negative exponent on top of a negative exponent. So again, lots of different ways to do it, but I'm just going to go ahead and give each of these distribute in the exponent to get that. Negative 8 times negative 3/4 turns out to be a nice little 6. Pretty easy. Now, this negative exponent, remember, that's the one where it brings it down. So it brings only the 16 down. The y to the 6th power didn't go down. It didn't have a negative in the exponent, so it stays on top. The only thing that goes down is the 16. And then from here, you can evaluate 16 to the 3/4 power, change it to root form, and you should get 8. And that's our final answer, y to the 6 over 8. I know, that was hard. This section is not easy, but we will practice a lot of these, all right? Go ahead and go try the homework.